everyone! We're back. Today we're talking about comparing quadratic functions to their parent function. The parent function of all quadratic functions is y equals x squared, or f of x equals x squared. It's x squared because that's quadratic. Quadratic means that the highest degree is 2. And it's the parent function because it's as simple as you can make it. There's no extra numbers. So today we're going to be comparing functions to that parent function. The first example of a way that you can change a parent function is by adding a coefficient. Adding a coefficient to a parent function is a stretch or a shrink. It's a dilation. A coefficient means a number in front of the x squared, a number that's being multiplied by the x squared. So for example, here in this function, we have g of x equals 6 times x squared. The 6 is a coefficient. Because 6 is greater than 1, we say that this is a vertical stretch. It's getting bigger because the scale factor, or the coefficient, is more than 1. It's a vertical stretch by a factor of 6. Here in this function, we have h of x equals 2/3 x squared. Here the coefficient is 2/3. Because 2/3 is less than 1, it's in between 0 and 1, we call this a shrink. So this is a vertical shrink by a factor of 2/3. What this means, really, is for a stretch, if your original function looks something like this, a stretch is going to make that longer and steeper. It's going to elongate it. It's like you're stretching a rubber band. It gets longer and the sides get closer together. A shrink, you're basically flattening that curve. So if that's your original function and you have a factor of 2/3, it winds up getting shorter and more spread out. So that's a vertical shrink. Another way that we can alter our parent function is by making the coefficient negative. Making the coefficient negative is a reflection in the x-axis. So we could just put a negative in front of the parent function, and that's a reflection in the x-axis. What that means is it's going to flip over. So instead of being a U shape like this, it's going to flip over and be a curve like so. Here we have two things happening. The negative still means there's a reflection in the x-axis. And then the 4 is a vertical stretch by a factor of 4. So you can have both of them happening at the same time. So in this situation, if this was your original curve, it would flip over and get taller and skinnier. Something like that. Another way that we can alter the parent function is by adding a constant term. Now, adding a constant term is a vertical translation. So for example, here we have m of x equals x squared plus 5. 5 is our constant term being added to the end of the function there. This is a vertical translation up 5. So we're moving the entire graph up 5 units. We're just kind of taking that u, we're not changing the shape of it, we're just moving it up so it's farther up on our graph. This over here, our constant is -4. So this is still a vertical translation, but now we're going down instead of up. So we're going down 4. So on this one, with our -4, it's a vertical translation down 4. So it's still the same shape. We're just moving it down 4 units and having it go again. All right, there's a couple of other ways we can change things. One of them is by adding a constant to x only. That's a horizontal translation. Horizontal translations move in the opposite direction. So here are 2 examples of horizontal translations. So in this first example, you'll see that there's a 5 and it's being added to only x. The difference between this and our previous function had x squared plus 5 and the 5 was just at the end. This one has the 5 being added to the x very first because it's in parentheses, and parentheses are first in the order of operations. So in this situation, we call this a horizontal translation. And horizontal translations move in the opposite direction that you'd think they would. So plus 5 actually means that we're going left 5. So if this was your original shape, your original parabola, it would just move that way. It'd be the same shape, just 5 units to the left. Over here, we again have a horizontal translation because it's inside the parentheses with the x, so it's only happening to x. So this is a horizontal translation. Right 4. So again, our shape just kind of looks like this, and it moves to the right 4 units. Then you can put these together in any way you want. So if we look down here, this function, r of x equals -1/4 x squared plus 8, this actually has 3 different things going on. So we have a reflection in the x-axis because there's a negative. We have a vertical shrink because it's less than 1 by a factor of 1/4. And then we also have a vertical translation up 8. So putting all of these together, if our original shape looked something like this, it would flip over and get wider and shorter, and then you would move it up 8 units to get your new shape. If you want to actually see how these translations, reflections, stretches, and shrinks are affecting your original parent function, I recommend going to Desmos and typing in your original parent function and then adding in the transformations, adding in the reflections, the stretch or the shrink, the translations, and it will actually show you how it moves as you add each new thing into your function. Desmos is really cool for doing this, and I recommend you play around with it because it will show you exactly how we move things around. All right, go ahead and try your homework assignment, and feel free to contact me via email if you have any questions. Have a good day.